Hello everyone and welcome to our channel mootechie. Today we're going to explore a really important aspect of how dairy plants operate: energy estimation. The dairy industry, as you know, is a significant consumer of energy when it comes to processing milk and all those milk products we enjoy. It's also important to note that developing nations are projected to see a large increase in energy consumption. India has one of the highest energy costs, and that makes energy costs a crucial factor, significantly affecting the profitability of dairy plants. So, economic and judicious use of energy is absolutely essential for achieving high returns in milk product manufacturing. In this presentation, we'll be discussing the estimation of energy utilization within a dairy plant. A milk plant can be broadly divided into manufacturing and auxiliary departments. Let's move to our next section. In this slide, we will see about sections of a milk plant and its energy consumption. We'll focus on the energy-intensive sections. First, we have the refrigeration section. This is crucial for maintaining low temperatures due to the perishable nature of milk products. Next is the pasteurization section. This involves heating and cooling milk to ensure safety and extend its shelf life. Then there's the boiler section. This produces steam for various processes, like heating, cleaning, and product manufacturing. For example, ghee. We also have the effluent treatment plant. This requires energy for treating wastewater. And the water supply and softening plant. This needs energy for water extraction and treatment. Finally, power generation, where diesel generator sets are essential for uninterrupted operations during power failures. It's important to remember that other sections, like packaging, quality control, and lighting, also consume energy. Okay, let's move on to how this energy usage is actually studied and measured. In this slide, we will see about data and methodology of the study. The information I'm presenting to you is based on an empirical study conducted at a dairy plant located in northeastern Haryana. Data was collected through several methods. This included actual observation, where researchers looked at water consumption, steam condensation recovery, and temperatures at different stages of the process. There were also personal discussions and interviews, where they covered electricity consumption in various sections, fuel usage, and operational details, with machine operators and those in charge. And finally, a review of records, which involved looking at electricity bills and logbooks detailing machine running hours, motor capacities, and current and voltage drawn. Now, let's talk about how we estimate steam requirements. In this slide, we will see about estimation procedure, steam requirement. Steam is vital for heating processes in a dairy plant. The steam requirement for heating a product can be estimated using the following parameters. M represents the quantity of the product to be heated in kilograms. S is the specific heat of the product. T is the temperature difference in degrees Celsius. And L is the latent heat of steam. The formula is steam requirement in kilograms equals M times S times T divided by L. Alright, moving on, let's discuss how we estimate electricity consumption. In this slide, we will see about estimation procedure, electricity consumption. Due to the absence of separate energy meters for each section, the study employed these methods to estimate electricity consumption. The watt-hour method was used for estimating consumption by lighting, fans, computers, air conditioners, and other general electrical points. Electricity consumption equals hours times watts divided by 1000 equals kilowatt hours. Power formulas were used for machinery in production and auxiliary units based on actual line current drawn, line voltage, and power factor, which was assumed to be 0.8. For a single-phase system, power in watts equals VL times IL times cosine theta. For a three-phase system, power in watts equals the square root of 3 times VL times IL times cosine theta. Next, let's explore how we estimate refrigeration load. In this slide, we will see about estimation procedure, refrigeration load. Refrigeration is essential for cooling milk and milk products. The refrigeration load, or heat to be removed, can be estimated using the following formula. Refrigeration load in kilocalories equals M times S times T. M is the quantity of the product to be cooled. S is the specific heat of the product. And T is the temperature difference in degrees Celsius. Okay, let's move on to the results of the study, starting with electricity consumption. In this slide, we will see about energy utilization results, electricity consumption by section. The refrigeration section accounted for the highest electricity consumption at 50.46%. This is crucial for maintaining the cold chain. Pasteurization and packaging consumed 21.39%. The effluent treatment plant used 7.25%. The boiler section consumed 6.10%. Water supply accounted for 3.83%. And other sections, including ghee, sweet-flavored milk, dahi, lassi, quality control and paneer, had lower consumption. Now, let's take a look at the refrigeration and steam requirements for specific products. In this slide, we will see about energy utilization results, refrigeration and steam requirements by product. Refrigeration requirements per unit are as follows. Pasteurized milk requires 61.35 kilocalories per liter. Lassi requires 46.90 kilocalories per 1000 milliliters. Dahi requires 46.70 kilocalories per 1000 milliliters. Paneer requires 45.49 kilocalories per kilogram. Steam requirements per unit are as follows. Pasteurized milk requires 0.12 kilograms per liter. Ghee requires 0.26 kilograms per kilogram. Sweet flavored milk requires 0.21 kilograms per 1000 milliliters. Paneer requires 0.16 kilograms per kilogram. Dahi and lassi each require 0.15 kilograms per 1000 milliliters. Let's summarize what we've learned. In this slide, we will see about conclusion. In conclusion, dairy processing is an energy-intensive industry where energy costs significantly affect profitability. Effective energy management is essential for cost reduction and improved returns in milk product manufacturing. The refrigeration section consumes the largest portion of electricity in dairy plants, typically around 50%. Finally, let's discuss some recommendations for improving energy efficiency. In this slide, we will see about recommendations. Here are some recommendations. First, prioritize optimizing refrigeration systems for enhanced energy efficiency and reduced electricity consumption. Second, establish regular energy audits across all dairy plant sections to identify and implement further energy-saving opportunities. Third, investigate the feasibility of integrating renewable energy sources to reduce reliance on conventional energy and lower environmental impact. Fourth, implement recovery and reuse of hot steam condensate to conserve water and thermal energy. And fifth, conduct a plant-wide upgrade of lighting to energy-efficient alternatives like CFLs to decrease electricity usage. In this slide, we will see about references. The information presented in this video is based on the following sources. Energy Management in a Dairy Industry by Swapnil Ratnakar. Estimation of Energy Utilization for Manufacturing Milk Products. Lesson 30 from the e-course Entrepreneurship Development and Industrial Consultancy. Pasteurization Process Energy Optimization for a Milk Dairy Plant by Energy Audit Approach by Modi A and Prajapat R. Thank you so much for taking the time to watch this presentation. I hope you found the insights shared today valuable and informative. If you have any thoughts, questions or ideas, feel free to leave them in the comments below. I'd love to hear from you. Don't forget to hit the like button if you enjoyed this video and subscribe to the channel for more content like this. Your support means a lot and helps us keep creating valuable content for you. Once again, thank you for watching and I'll see you in the next video.